In this video, I want to explain a few ways in which you can convert one data type to another. Now, one of the simplest ways, and one that you see used in many programming languages, is by using a technique called casting or coercion to, for example, change one numeric data type to another. Now, you can see an example here. Here I'm programming a tax calculator. I'll just show you it in operation first. So I put in a subtotal and the calculator calculates the tax and it adds the tax to the subtotal to arrive at the grand total, what I'd actually pay for the product that I'm in theory buying. Now behind the scenes there's a lot of conversion going on between one data type and another. I'll look at this in detail shortly, but first I want to show you how to cast one numeric data type to another. Here rounded total is declared as int, an integer, a full number, with no floating point part. Grand total is, however, a double. That's a floating point number with a point value followed by some digits. For example, 100.01 would be a floating point number, whereas 100 with no point would be the integer. Now, in order to convert the double data type to an integer, I simply put the int data type in a pair of parentheses before the value, before the variable, which here is a double, that I want to convert or cast to integer. So rounded total is now the integer version of grand total. Let's see that in operation. So let's enter a floating point number, do the calculation. You can see that the tax and the grand total are shown as floating point numbers. But my integer version of this number, the one that I calculated using the int cast, is a full integer number, 120, with no floating point part, and that's displayed in the caption of the form. This is not always a convenient way of converting. You cannot, quite simply, convert all data types to all other data types simply by casting them. Now, a good example is shown here. In order to do the calculations, I have to work with doubles, with numeric floating point data types. So all these calculations here are done on numbers. But when the user enters some text into the top box on my form, the subtotal here, this is actually a text box. I could enter ordinary alphabetic characters like that. It wouldn't make any sense. In fact, my calculation would go horribly wrong if I did that. But I just want to show you that to demonstrate that while that might look like a number, actually C# treats it as a sequence of characters, a string. And it can't do calculations on a string. It has to convert it to a number first. Now this is how I do this. All the sample code for the projects in this course are available for free download from the Bitwise Books website. I can do this using the double structure. So here I use double with a capital D. Don't worry what a structure is at the moment. I'll discuss that later in this course. So I want to use the method or function called parse, and that belongs to double. So I do this by placing it after a dot following double spelt with a capital D. Then a pair of parentheses containing whatever value I want to convert to a double. Here I've got the text field of the subtotal TB text box, subtotal TB dot text. That returns the string that the user entered in that box. And if it can be converted to double, then the double dot parse will convert it and return the numeric equivalent of the text. When I've done all the calculations, I now have the problem that I want to display the values back in text boxes. I have the tax text box and the grand total text box. But my tax and grand total values are doubles. So I have the opposite problem to the one that I started out with. Now I have numerical values and I need to convert them to strings. It happens that the toString method gets me out of this fix. I use the toString method directly with the name of the variable that I want to convert. So the variable tax dot toString returns the string representation of the tax variable, which was, remember, a double. And the same thing is true of grand total. And there are many other methods and classes in the .NET framework that we'll be using with C# that can help us convert one data type to another. Now, before moving on, I just want to explain a couple of other things that you'll see here. First of all, these usings up here. Using is a keyword. A keyword in C# is a special word. It's not like a variable. It's not something you can create yourself. It's predefined. And things like using, namespace, public, class, void, these are all keywords. You must use them exactly as they are because they have a special meaning. Now, when you write using followed by something like system.text, you are telling C# to, in effect, import the contents of whatever it finds in system.text. System.text and the other names up in the using section up here are called namespaces. They're like modules which contain various useful bits of code. And in order for your program to be able to use the contents of those namespaces, they have to be included in your program. And the syntax for that is using followed by the namespace. And in fact, most of the time, you won't need to enter them yourself because C# will take care of that for you. But just for an example of what would happen if I didn't have the correct namespace imported. Now, form is found in the system.windows.forms namespace. I'll comment that line out. And look, there's a red squiggly appeared under form. Hover over that and I get an error message saying the type or namespace name form could not be found. And it suggests, are you missing a using directive? Well, yes, I am, because I've commented it out. I'll also explain comments. When I comment something out, as here, I'm removing it from my program. I'm telling C# ignore this line. Now, normally when I put in a comment, it will be to add some sort of documentation. And it's good practice just to put one or two lines here and there to clarify what your code means. So, for example, this entire block of code here is what does the calculation. So I put a comment up here saying what it does. Calculate and display tax and grand total based on subtotal. Now, if I wanted to put a very large comment, I could use this type. I put a slash followed by an asterisk. As I press carriage return, Visual Studio puts an asterisk on each new line for me, and I can now start writing some comments in. Until I terminate the comment block with an asterisk followed again by a slash character. And you can see that I know when I've terminated the comment block because the colouring of comments, in this case it's green, but it might be a different colour in your Visual Studio setup, the colouring ends at the end of the comment. So this type of comment lets me put comments on multiple lines. This type of comment lets me put a comment on a single line. And wherever I start this type of comment, the comment begins and the comment ends at the end of the line it's on. To learn programming in depth, enroll in one of my courses or read one of my books. More information at bitwisebooks.com.